Hello everybody, this is Mr. Reese. I wanted to put a quick tutorial together for you on graphing using Excel. You guys had some homework last week involving this data in this worksheet, graphing point 4, physics problems point 4. So basically IB is going to want their graphs to be in a certain way, and I want to kind of go over those details. They're going to want trend lines, they're going to want equations on the graph, they're going to want error bars on the graph, that kind of thing. So I wanted to put this together for you in case you were unfamiliar with how to do that. So the first problem involved you graphing pressure and volume. And it says the pressure, right? The pressure is the independent variable x. So all these pressure values, 1, 1.5 in atmospheres. So this is 2.5 of Earth's atmospheres, right? So all these pressure values are on the x-axis because it's the independent variable. They go in the first column on Excel, like I put them here. Okay, and then the volume is the dependent variable, and so that's in the y, and the y goes in column B. And I put all that data in. Okay, so I'm going to basically minimize that and maximize this now so we can work in Excel. Okay, and so the way you graph this is really simple. You put the data in, like I said. Notice how I didn't put any units here, and I didn't put pressure and atmospheres and volume. I didn't put any of that here. I just put the numbers in. Okay, so sometimes students put words in too. You're just trying to put all the data in numbers, and you highlight all the data. And you go to Insert, you come up to Charts, and you're going to pick Scatter. Don't pick any of these ones with all these lines, and this looks cool, but don't pick this one. It's not how scientists are going to represent their data. It's not how IB wants to see it. They want to see this simple one, so you click there. And the problem with what we see now is it doesn't have titles for our axes, it doesn't have an equation, there's a lot missing from our graph. So the way you can easily, quickly fix that is you go to Quick Layout, and I recommend this one that has FX on it, which means function, and I click that, and now I have the title, I have the axis title. I can take this and bring it over here, which is the equation of this trend line that Excel put on there, and so now it's looking a lot better. Okay, it's not done yet. For instance, this axis title needs to be updated. So remember, this is pressure, and then you put the unit in parentheses, so pressure in atmospheres, right? And you can do the same thing for volume, and you can do the same thing for the title, okay? But let's talk a little bit about this trend line. This trend line doesn't fit our data, first of all. Our data has a curve to it. Our trend line is linear, and you should be familiar with slope-intercept form, so y equals mx plus b. So literally, this equation means y, which is the volume, is equal to this number times whatever pressure atmosphere we put in. We could put 1 in, plus 393.95. So you can use this math to basically find out what the pressure and atmosphere would be for any coordinate in this graph. But the problem is, this equation goes with this line. So literally, if you put in a pressure of 4, you'd get a value of your atmosphere of right here, when we know it should be here because our trend line should follow our data. So this is a bad trend line right now, and it's not one you'd want to keep on your graph, okay? So what we're going to do is we're going to highlight that trend line and press delete, and it's gone. It's not the right one. Now we're going to need to add a trend line. The way you do that is you right click on a data point and you come down and you add trend line. When you do that, a menu pops up over here and with different options. Now the default is linear, and obviously, like we said, it's not a linear trend, so we need to change this. Here's a curve, so maybe it's exponential. So that line fits our data better, but it seems to be below our data, above our data, and then below our data. So it doesn't fit the data great. And we can even display the equation on chart. And we can let's see, go back to here. Let me X out of that and right click, and I want to also display R-squared value on chart. Okay, so this R-squared value is 0.92, which is pretty good actually. The R-squared value tells you how closely on average this line that Excel has created fits the data. And the closer you are to 1, the better it fits your data. So 0.92 is pretty close to 1. We go back to linear. Linear doesn't fit our data much at all, really. I mean, at least it has this downward trend, which is decent. And so this R-squared value is 0.729. So exponential is actually better than linear. Well, what if we go down to logarithmic? Now we're at 0.919. That's still better than linear. Polynomial. Okay. My advice to you is stay away from polynomial. The functions that you're graphing in IB Physics this year will not be polynomial, and it's one that oftentimes will have a high R-squared value, but it's actually because you can put several functions together to fit the data, and it's not the one that you want. So stay away from polynomial. Okay, let's go to power. Okay, that is perfectly fitting our data because our R-squared value is equal to 1. And so that is the equation that fits the data the best. So now what that means is if you were to put in any pressure in for X and multiply that by 500, and this X to the negative 1 means literally 1 over X. So you would take 500 divided by 4, and you're going to get the 125, which is what is right here. So that makes a lot of sense. So this is the correct equation for our data. We did that by kind of going through here and checking when R squared equals 1. Okay. Now, another thing IB is going to want, besides the correct trend line, is error bars. Okay, so if we go back to your worksheet, it says pressure is plus or minus 0.2 and volume is plus or minus 5. Okay, so we need to incorporate that into our graph. Okay, so the way you do that is you press this plus, and you come down and you click error bars. And it does something by default. And it looks like all these error bars are the same, so that's not what we want. We know we have specific values. So we're going to go to error bars, and we're going to start going to more options. Okay. So let's do a fixed value because that's what's given in this problem. So kind of going back again, let's start with pressure, which is our X. Our X pressure error bars are plus or minus 0.2. So we're going to go to fixed value. We're going to go 0.2. We're going to have both directions. And so that, I think that is it. Okay, so we did that, great. So as you can see, our error bars just got a lot more narrow in the X direction, right? Now, let's click the Y direction, and we know these are plus or minus 5, so again, that's a fixed value. So we press 5 and press away. And now what you'll notice is you don't really see those error bars too much because 5 vertically is very small on this graph. It doesn't mean the error bars aren't there. So if you go to plus and error bars and go to more options, right now it's highlighting the X ones. And if you want to get the Y ones, you actually have to kind of select that data, which is hard now that we made them so small. But the point is they're actually on there and they're so small that you can't see them. Okay, I want to show you one more case. So let's say, so these ones are changing by a percentage. So let's just apply this percentage to our current data. Okay, I know it's for a different graph, but let's just kind of, so I don't have to create a whole new graph. So again, let's click on the error bars format error bars. And yeah, series 1 X error bars. If we want the Y error bars, we can press that. Okay, good. Now let's go to a percentage. And it looks like on this case, our error bars in the Y were plus or minus 4%. So if we go back over here, we can just change this to 4. And now we can see error bars again because 4% is bigger than 5 for these numbers, except when you get down here. 4% of 100 is 4, so that's why you can't see it down here. But 4% of 500 is like 12, and so it's much bigger. Something like that. Okay, so you kind of get the idea. You can actually customize these error bars, and let's say, like on the last one, you probably noticed that the error bars keep changing. Here it's 0.1, 0.1, and then it goes 0.2, 0.2, and then it goes 0.5, 0.5, 0.5. How do you deal with something like that? Well, that's going to happen in the lab. So what I'm going to do is I'm going to put the error bars for X in column C. Okay, and so let's look at what they are again. The error bars for X are 0.1, 0.1, 0.2, 0.2, 0.5, 0.5, 0.5. So 0.1, 0.1, 0.2, 0.2, 0.5, 0.5, 0.5. And I'm getting something off real quick. So it's, oh, okay. 0.1, oh, there's just less data in this one. Okay, anyway, so let's say this one is 1. Okay, so now we're gonna highlight the horizontal error bars again. Okay, I'm gonna right click on it. We're gonna format error bars, and we're gonna go to custom, and we're gonna specify value. And this chart comes up. Okay, so I'm going to delete what is given for positive error bars, and I'm going to highlight all of this. And I'm going to come over here and delete what's put in for negative, and I'm going to highlight all of this. And I'm going to hit OK. And now what's happened is the error bars have gotten bigger in the X direction as the data gets bigger, just like I have said here. These 0.1 you can't see. By the time we get to 1, if this is 9, then it goes all the way to 8 and up to 10. So you can kind of see we've been able to customize error bars. Okay, so that is my tutorial on making graphs that are up to IB standards. You're going to want to practice that, and any graph that you make in the lab will have to have titles, axis titles, trend lines, error bars, and an equation that best fits the data. Okay, I hope that helps. Thank you very much.